I'm going to explain the closed unit interval functions in Affinity's procedural texture filter. There are three functions with CUI in the name: tocui, tohcui, and mapcui. CUI stands for closed unit interval. Tocui assumes you want to convert a harmonic function from a -1 to 1 range to a range from 0 to 1. Tohcui assumes you want to convert a function in the range from 0 to 1 to a range from -1 to 1. Mapcui turns out to be a different way to write a smooth step function, and it is the smooth step lin function. It's identical to the smooth step lin function. If I wanted to convert a number in the 0 to 1 range to a -1 to 1 range, I could multiply by 2 and then subtract 1. I could also subtract by 0.5 first and then multiply by 2. So either way, you get the same answer. If I wanted to convert a number in the -1 to 1 range to the 0 to 1 range, I would divide it by 2 and add 1/2 or 0.5, or I could add 1 and then divide by 2. So the tocui and tohcui functions give you a quick little utility to convert between these two ranges. I'm going to start with a new document. I'm going to go down to Legacy PC, which is 1024 by 768. I'm going to convert the 768 to 1024 and create the document. I'm going to choose the background color black and choose the fill tool and flood fill it with black. Choose the move tool, and I'm going to add a live procedural texture filter. I'll add a single equation and assign it to the three color channels R, G, and B, and I'll add a single real number input A, label that scale, and set that equal to 8. I'm going to start with a coordinate system. VAR V equals vec2, a two-element vector for my coordinates consisting of Rx, relative x, and relative y. That way I can move it when I double-click, times my scaling factor A and divided by W, which is the width of the document in pixels. I'll start with tohcui. So let's say I have a function. I'll use the oscillator of v dot x as my example function. And so you can see in the scope that it starts at 1, goes down to 0, back up to 1, back and forth like that. And you can see it starts at a bright value, dark value, bright value, dark value. Now if I wanted to change this to the 1 to -1 range, I could use the tohcui function, tohcui, and that changes it to the 1 to -1 range. Now I can't see the negative numbers on here. However, if I add another equation and turn off the green and blue channels up there, turn them on down here, copy this, paste it down here, and make it negative, then those negative numbers are showing up as the cyan color over here. In fact, if I switch over to an RGB waveform, there you can see it a little better. So that is tohcui. I can go the other way. Say I have oscillate of v dot x, and I want to convert that over to the 0 to 1 range. I can do that with tocui, and it will convert into the 0 to 1 range. So this function isn't super useful because there are already harmonic versions of almost all of the functions where you would use this. Now, if you had created a sort of complicated formula and you wanted to convert that to the other range, So let's say you had some random noise that you wanted to both have in the range from -1 to 1 rather than just 0 to 1, because you wanted to add it to, something else to make an effect. Then you could use this to quickly do that. You wouldn't have to, convert everything. The other one, though, is the cell noise. So there is no harmonic version of cell noise. So if I wanted to try to create one, I could use tocui, cell noise, v.x, v.y, and 1, and there's the harmonic version of cell noise. Now I can only see the positive part of this, but if I again add a new equation, copy and paste this down here, and then make this one negative, I could see the, turn on the cyan, and then I could see the negative version of that. Now these also work with vectors, and so if I go back and put in, if I look at just my coordinate system vector, it looks like that. Now if I take the fraction of this and just look at the fractional part of that number, you can see that it's changing like this. And if I double click here, the origin is right at this corner. Now if I do the, if I go in here and do 2CUI V, okay, you can see the scale is now larger, and if I double click where it looks like the origin is, it shifts it over. Because we're not just multiplying, we're adding. And then if I do a 2HCUI, it gets very small, and this time it shifts it over the other direction, because we're not just multiplying, we're adding a value to offset this. So it works with vectors as well. So this function also works with vectors. Next I'm going to look at mapcui. This requires 3 inputs, so I'm going to add 2 0 to 1 range inputs, label one E0 and the other one E1. And the one is where you'll start off at 0, the other one is where you reach 1. I'm going to take oscillator of v.x as my starting function, and then I'm going to use the mapcui function with this, mapcui, and I'm going to put in E0, E1, and my oscillator function. And so as I move over this E0, that's going to shift the position of the 0. And as I move over the E1, it's going to shift to the position of the 1. So this actually is identical to the smooth step linear function. There's one weird thing that really threw me off with this function. In the Affinity's documentation for this function, they have mapcui and then the texture and then the 2 edges listed at the end. So the 2 edges are following the input for the texture. And I tried that and I got some really weird results, but no, it's not that way. The E0 is first, the E1 is next, and then your pattern comes third. So use it that way. The documentation is wrong for this one. So 2CUI and 2HCUI both work with vectors. mapcui does not work with vector inputs. All right, let me know if you have any comments or questions, and thanks for watching.